Hello and welcome to SudoKanard. We're here to solve this killer Sudoku by Polish author Krystian Świderski. It was featured in the latest Sudoku Grand Prix and it was worth hoping 113 points, which is a lot, especially for such a common variant. But the puzzle was pretty difficult, I must say. I solved it in very reasonable time during the contest, I think something like 15 minutes. And I think it just shows that I'm very well trained in Kira Sudoku. You must appreciate the fact that I test solved the whole Kira Sudoku book by Akash Durrani a few months ago. So that there were 120 puzzles in this book. And I'm mentioning this because this Kira Sudoku that was featured in Grand Prix is a kind of masterclass in using all sorts of techniques that may be used in Kira Sudoku. It's really a catalog. And I'm about to show this. So the rule of Kira Sudoku is that in such a cage, all digits are different and their sum is given in a corner. So what kind of stuff what kind of knowledge of techniques of Kira Sudoku are in use here? Well, some of them are just the basic knowledge of decompositions. 23 with 3 cells can only be 6, 8, and 9. Another one is, in a similar fashion, 16 in 5 cells can only be 1, 2, 3, 4, 6. And I won't pencil mark all 5 digits here, so I pencil mark the missing digits here, 5, 7, 8, 9 for the remaining 4 cells. Now something else that is important is that the sum of all digits from 1 to 9 is 45. And here we have an 8-cell cage summing to 36, which means that 9 is not in here. So all digits appear in this cage except for 9. And 9 does not appear here, so 9 in this column must be here. And it means that the remaining 4 digits sum to 10, and 4 digits summing to 10 have to be 1, 2, 3, 4. And that's assuming all 4 digits are different. Now there are several places you can look, and I'm thinking that here we have some interesting geometry, which is that those 2 digits are different from all 4 digits there. And from 9, obviously, but those are more important. Those digits, so those ones, they're on the same row, and they see this one, they're in the same box. So those digits are different from 1, 2, 3, 4. So the minimum value here would be 5 plus 6, which is 11, which means that the maximum value for those is 4. So those 2 digits sum to either 3 or 4, so they are either 1 plus 2 or 1 plus 3. 1 plus 3 works with 5 and 6. 1 and 2 means that those would sum to 12 without using those digits, in which case they will be 5 and 7. So there will always be a 5 in here and a 1 in there. And that's not a 1. Let's move on. Another way of applying the 45 rule is to see that those 6 digits sum to 38, so that those 3 digits sum to 45 minus 38, which is 7, so there must be 1, 2, and 4. And those must be 3, 5, and 7. Here we have a total of 28, so those two sum to 45 minus 28, that's 17, 17 with 2 digits can only be 8 plus 9. Here we have a 6, 8, 9 triple. Well, another way of saying this is that this digit here is different from those two, and it's also different from all those digits. Well, none of them is 8 or 9. So this digit inside this cage can only be here, so that's not a 6. Where else do we look? I think now we have to advance to some more advanced technique. You can see that this whole row is included in the grouping of those 3 cages. And the total sum of those 3 cages is 52. That's correct. Let's remove this row, which sums to 45. We are left with 52 minus 45, that's 7. So those 4 digits sum to 7. And you must appreciate the fact that 3 different digits sum to at least 6, 1 plus 2 plus 3, so that this cannot be higher than 1, so it has to be 1. And now those 3 digits sum to 6, so they must be 1, 2, 3, and this is obviously not a 1. So the 1 is in here. Those digits include the 4 and the 6, and something like this. Now let's have a look at this row. We already have 19 here. 11 plus 7 plus 1 is 19. So the complement to 45 is 26. So we have a total of 26 with those 4 digits. And something to appreciate is the fact that those 4 digits here sum to, sorry about that, they sum to 29. So those 4 sum to 26, those 4 sum to 29. So this digit is 3 less than this. So this is from 2, 4, 5, and 6. And a few values may be ruled out. 5 here would cause this to be an 8, and 5 would repeat in this area. So that's not an option. This is not 5, this is not 8. 2 here would mean that those 2 digits sum to 19, which is impossible. So that's not the 2, that's not a 5. Now, we know that 5 is here. 1 is here. So this 7 does not use the 1, it's not 1 plus 6. Doesn't use the 5, so it's not 5 plus 2. So it has to be 3 plus 4. And now this 4 is impossible, that has to be a 6. And this is 3 units more, so this is a 9. And we can remove 9 from those cells. That's a 6. Those 2 digits must sum to 15. 5 here would require a 10, so 5 does not work here. And those 2 sum to 15, so this is 7 or 8. And this row still needs a 2 and a 9. All right. Let's have a look at this 18 cell, 18 cage, sorry. So that's 1, this is 2 or 3. So those 2 digits must sum to either 15 or 14. And actually 15 is impossible, because there are 2 ways of making 15 out of 2 digits. One of them is 7 plus 8, which is impossible because there would be no value for this. And the other way is with 6 plus 9, which is impossible because 6 is not available. So those two digits may not sum to 15, so this can't be a 2, that has to be a 3, which disambiguates that and removes 3 from the values here. Now those two digits sum to 4, so those two digits sum to 14 without using the 6, so they must be 5 and 9. And this 3 is removed from those cells. There's a 2 in here, 2 is not there, so 2 must be here. 8 and 9 here, so that's not an 8. 8 in this cell must be here, and this is 7. So 2 disappears from this, 7 disappears from there. Here we have 3, 4, 6, I think, that's correct. And here we have 1, 7, and 8. And here we have 4, 5, 6. So let's do some Sudoku in this area. Here we have a 1, 2, 4 triple. And 4 inside this triple is here, so that's not a 4. That's not a 4. We have a 1 in those cells, so that's not a 1. This is probably not the most important part to look. This 10 cage does not use the 1, does not use the 3, so it must be made of 2 even digits without using the 8, so that's a 4, 6 pair. We can remove 6 from this cell. Actually, there's a 6 in here, so that has to be a 4, and that's a 6. This 14 cage is either 4 plus 6, 8 plus 6, but that's impossible because those digits are not available, or 5 plus 9, so it has to be 5 plus 9. There's a 9 here, so that's a 5, that's a 9, and that's a 5, that's a 9. Where do we look next? Oh, that's a very interesting point. There's a 1 here, so there's no 1 in here, but there's a 1 in the 36 cage, so the 1 is somewhere here, and that has to be a 2. And conversely, this 2 is now no more in those cells, but it must appear somewhere inside this cage, so the 2 must be somewhere here. We can remove 2 from those places, so that here is a 1, and that is a 3, and that is a 4, which means that none of those are 4s. That's here, that's a 2. And now that those digits sum to 4, those two digits must sum to 11, so that's a 6 here and a 5 there. Right. Here we need, well, this one here goes there by the rules of Sudoku. Here that's a 5. Here we must have 7 and 8. Here that must be a 2, which means that this is 1, this is 4, 4 I said, and this is 2. That's not 1, that's the 1. Let's not get carried away. That seems to be all for this part. Here we need 1, 3, and 7. 1 is not here. This row still needs 4, 7, 8. 4 is not there. We have a 7, 8 pair here, so that's not an 8. 5 and 9 are not here, so they must appear on this column, so that has to be the 5, that has to be the 9. which gives 8, 6, 8, 8, I said 9. 6 is not here, so that's a 4. That's the 6. That's the 4. And this column still needs a 6. Here we have a total of 20 plus 16, that's 36. To get to 45, we need a 9 there. Oops. So that's a 2, that's a 9. Here, this 5 goes here, and it goes there. There's a 7 here, so that's 8. That's, what am I doing? That's a 9 here. That's 8, that's 7. That's 8, that's 7. I still need a 2 here and a 3 there. All right. So let's get back to this area. This row still needs 4, 7, 8. And something of interest here is that 3 and 4 are definitely not here. So they are somewhere inside this part of the 36 gauge, because 3 and 4 must appear somewhere in the 36 gauge. So that this is a 6. And then this 6 does not appear anywhere here, but it must appear somewhere on the 36 gauge. So the 6 is here somewhere with the 2. And this is from 7 and 8. This one here disambiguates some stuff. And we're getting near the completion. Those 9s here must appear 9 must appear somewhere on this row. That's here. 6 must appear somewhere on this row. That's here. So that's a 2, that's a 6. And this is from 3 and 7. This column still needs a 2, so it's here. This is from 7, 8. So we have 8 here, we need another 11 from those digits. 11 from 4, 5, 7, 8, they have to be 4 and 7. So that's 7 here, 4 there, 8 here, 7, 8, 7 and 4. 3 here, 7, 3, 7, that's the 1, that's the 3, that's 8, that's 7, that's 5, that's 8, and we get a 1 here and a 5 there. And so this wraps up the so of this magnificent Sudoku by Krystian Świderski. Really a beautiful use of various techniques, of knowledge of decompositions, of geometry. Really enjoyable. I think my solving path during the contest was not exactly the same, because as you have seen, there are several places to look. It may have been less smooth because, well, I was discovering the puzzle. During this video, I was definitely using my prior knowledge of how this was constructed, but really, that's a very nice puzzle. I may have rated it maybe around 90 points rather than 113. But then I may be biased by the fact that I have practiced Sudoku so much, and that that's a variant I really love. So anyway, thanks for watching this video. See you soon on SudoKanard.